difficult is a difficult way to get this kind of parameters. By this way, by this calculation, okay, the heating value we can know that. We can know that. From this way, from this function, we know that CH4 is the BTU, the heating value CH4 is 3 times of the H2. So H2 is not so important for heating value. CH4 is very important. So this reason, CH4, you should get a good result of the CH4. 1% of the CH4 is equal to 3% of H2, and 2% of the CO. So the measurement of the CH4 is very important. CHM also more than that, but in gasified system, CHM is very less. And also biochar process, CHM compared with the CH4 is some less. So it's important, but not so important. So the important thing is that the vital important is the CH4 for testing. So by this way, we can get the digital gas analyzer with CO, CO2, CH4, CH, H2, O2, and the heating value. So this way, this analyzer we produce in 2004. At that time, in 2005, we know everything with that, and then now sold in China, and also sold in Brazil, Austria, and many countries. Okay, I will do some application case. Sorry, yes.
Before you go there, so I'm curious why for the CO you decided to use an NDIR. It seems that you could use a very basic electrochemical cell because you can solve the cross sensitivity between the CO and the H2 and CH4 by your thermal conductivity for the hydrogen and your NDIR for the CH4. It doesn't seem that you would need the accuracy of the NDIR on the CO. We think that you could mathematically solve with a much dirtier filter or cross-sensitive filter on the CO.
So I cannot understand very clear. It means that you want to use an electrochemical sensor for CO?
I'm asking, it appears that you could use a simpler sensor on the CO, that you have more information than you actually need to solve the problem. Okay? The NDIR sensor is much more expensive than the CO sensor, correct?
In fact, for us, for NDIR is not so expensive.
Okay, well, I thought they were. So that's the basis of the question. I've assumed that the NDIR sensors are much more. When we bought them here, they have been much more.
No, NDIR have different kind of NDIR. Now, the very simple NDIR can cost just maybe $40. A very simple one, NDIR, now maybe $40, $50. A very simple one. It just depends on the accuracy. Yeah. So if for industrial application, maybe more than that, because you should keep the temperature constant, and you can use the infrared source more with high accuracy and so on. Okay. So I tell you some application. The one application is we use it in China for online monitor system for the calcium carbonate furnace off-gas monitor system. Before that, this kind of the furnace was used for the CaC2. Do you know that? CaC2 is used for solid into the water, and then the gas come out, C2H2. Yeah, this kind of, now China is the main manufacturer in the world to do this kind of the chemical. Formally, this kind of gas come out is mainly the CO, sometimes CO2 and CH4 and H2 and O2. H2 is very important because the leakage of the moisture. The moisture leakage and then H2 come out and then expulsion. Generally in China, you see in this kind of plants, the house have low windows. Do you know why? Yes. Yeah. This reason. So the monitor here is very, very important. So it's very, yes, it's true that no window. Heat-only is not necessary. So sometimes here it boom. Like that. Yeah. So we have installed the 5-gas analyzer monitor system in China. I think maybe in one company, 40 piece, 40 system like that. They have many furnaces. He's the main producer in China to do this kind of business. This is the first one. The second one is now I know India friends come from India for biomass. Here is an India company. I know India Institute IIT in Bangalore. Bangalore, he is very famous for do the biomass gasification for power generation, especially in Tamil Nadu. Tamil Nadu for power generation because in India some village have no power. They should use this kind of separate power system. He's a main developer of in India. The second one is I think Jim maybe know is that Akin Scientific in Baroda. I had visited them. Dr. Jan, he graduated from the MIT and then in India. He does this kind of business very well in India. So I had sold the gas analyzer to IIT for research of biomass research here. This is the second one. The third one is for underground coal gasification. This is in China. Because especially for the brown coal, high moisture. If you take it out, the shipping is a problem. Especially just like the in UK, USA, North Dakota. In North Dakota, the Grand Forks, North Dakota here, they are very rich in the brown coal. When they take it out that, it's very difficult to ship that. And the freeze, you cannot remove that. And then it's just carry the water for spring, but no worry. So in China, they are very rich in this kind of coal. They have no ways to carry it out. And then with the gasifier underground, the gas come out with high pressure. He's a very famous company, a big company in China, to do this kind of research in China. So we supply this monitor system for them, for the underground coal gasification monitor system. The first one is that in 2006, I sent one analyzer system to Logical, that's in India. For this Logical, this coal gasifier company, I think it is the main coal gasifier company in India. Because the company is very near Morbi. Morbi is a ceramic center for manufacture center in India. So we send this kind of machine for monitor the gas. Generally, this kind of gas, this is a gasifier, and then the dust, and here is the ESP for tar remove with the electrical ESP with the electric to remove that. So here the monitor the gas and also the oxygen. Is oxygen more than 100%? Then expulsion. This is a big problem. So monitor oxygen is very important. Also the gas composition. Gas here, out here is to the combustion for ceramic. So this is very important also for the gasifier and also very important for the combustion. So by this kind of system. Formerly they use like the offset one. This is used for the not this is used for the calorie, heating value measurement by combustion of the and water. Just heat the water, see the temperature. How about the temperature? Hello?
What is the maximum oxygen that they felt was safe in the electrostatic precipitator before they could have a combustion event?
For what of the oxygen level?
What is the highest level of oxygen that they wanted to see?
1%.
1%?
Yeah, in China, if more than 1%, the ESP should be closed. No electricity. If more than electricity, a problem. A problem. 1% is very important. In fact, in China, also for the biomass gasification, in China they are installed about 300 pieces, more than 300 systems of the biomass gasification station in China was installed. Now the big problem is that it's like a tank. Do you understand? It's a big tank here for the keep the gas in a tank, and then generally for cooking, not for power generation, for cooking, for the farmer, for cooking. So its tank, if the oxygen level is very high, there's some problem there. Especially when there is not good weather, is a sun, and then a big problem. This is the reason now in China, now the government pay more attention on the safety of the biomass gasification. Sometimes it's a trouble. Okay, in India they use this kind of machine for the heating value measurement. So they want to use here. He's a master degree student, a master degree engineer, a chemical. He do the heating calorie measurement for his company. So they want to buy our automatically gas composition and heating value analyzer for the system. They want to do integration. And then the last one is the biochar process. Now is one of the largest charcoal company in Brazil. In last year, I have visited Brazil. Here is wood. His wood. Come from plantation. Just a plantation for biomass. Biomass very high. I think maybe more than 50 meters. So very high, very thin. This kind of the plants. Many oil inside. So they use this kind of the biomass for charcoal. For charcoal. Here is the king. This is a big one. So they want to use this kind of gas for power generation. For CDM process. Do you know CDM? Clean development mechanism. Carbon trading in the world. So want to do this kind of business. So they want to know the gas quality and also for combustion, also for power generation. So they buy our system for his process monitor and also for the optimization of for the combustion process. So they buy this kind of system. Okay.
Is this exothermic? Exothermic?
Yes. Yes. MG, Minas Gerais. Yeah, it's about from the center of the Rio and São Paulo. Near the center, yeah.
He was asking if it gives off energy.
Energy?
The process is exothermic.
Exothermic.
Yeah. I know steel company. Yeah. So he uses charcoal to replace the coking.
Okay.
Yeah. In China, coking. In Brazil, charcoal. Maybe Australia. Yeah. Okay, that's all. Thank you.
How much does one of your detectors cost?
How much?
How expensive is one of your detectors?
Just analyzer?
Yeah, the gas, 6 gas analyzer with.
6 gas is about 8,000. Yes. Yeah.
How'd they find out about you down in Brazil?
Sorry for my bad
So
language.
you're analyzing people in Brazil, right?
Yeah.
How'd they find out about you?
How they found?
How did they know about it?
How they know me?
Yeah, how'd they know about your gas analyzer?
How they know our company?
Yeah.
From the website. We do that. If you see the produce gas analyzer in the website, we are the first one. Yeah. Every year we spend about $10,000 in Google.
2 more questions briefly. Now, did your website say you sold 3,500 of these things last year?
3.
How many did you sell last year?
Last year, including China.
Period.
Oh, totally, 1 year.
Uh-huh.
I say maybe 200 to 300.
200
Every year.
each year.
Each year, yeah. I say maybe 80% is in China.
Okay, so is that the total units that you've sold, or that's outside of China?
1 year,
Yes.
just 1 year.
Right, but total in 1 year? 200-300?
Totally, I think maybe near 1,000 pieces.
Okay.
Yes.
1,000 units
Yes, yeah.
per year.
Totally, no, several years. Our company, new company, just